learn for my final project, which is basically a data analysis program which analyze the data and predict the future result. So how our project work is related to this. So basically our project collect the data from online cloud and analyze that data and show the predicted result and also show the graphical representation of that result. And for our programming, I use the platform Colab Google Python, which is an online platform for Python. I choose this program because it is easy to use and time consuming. It is already user friendly. And let's come to the program file. Click on the link for moving to the program file, but it takes time. So I already opened it in my browser. So let's come to the program. So it's description of the program. So it is this program uses artificial recurrent network called LSTM, which is long short-term memory, which is able to store past information. LSTM is able to store past information. So I use this memory network to predict the closing price of any corporation you can take. So next, I import the libraries. So first we import the math library for mathematical operation like square roots and all. Next is pandas, which is Python based data analysis toolkit, which is used for converting entire data table into NumPy matrix. So now what is NumPy matrix? So NumPy matrix is basically used for linear algebra, Fourier transform, matrices, statistics, and all related work. So next we import minimum max scalar. So minimum max scalar provides range to the training data between 0 and 1, which is provide the maximum and minimum value of the data, which is heavily required for the further analysis. Next is import sequential. In import sequential, we allow you to create model layer by layer. It is usually used for layering. Next, we import the dense and LSTM. So basically, dense is used for creating dense layer. So what is dense layer? It is most common layer which do the below operation on input and return the output. So basically, it is for output dense, and LSTM is for LSTM layering that I already told earlier. And next is matplotlib pyplot. Pyplot is used for plotting the graph. So next we get the stock code. In stock code, means we creating the data frame for our network. Mm, like for which company we want to create or we want to analyze the data. And next we are providing shape to the to our frame, like we rows and column we are providing. And next is visualizing the closing price, means a graphical representation of what is the closing price, what's the graphical representation. So as you see, after running we get the closing price representation like this. Here we got that in 2021 Apple has already got a very high stock price, which is due to, I think, because of the release of M1 series, which is latest of Apple, which is a very good technology. And next we create a data frame, a new data frame for our network. And in this data frame, which next we create the numpy array. And then we assign training data length, which is into 8. This is by into 8 because we are providing 80% of our data. So next is the scaling of data, which is for as scaling is basically for the advantage for pre-processing, and it is helping modeling of data, and it gives the value of data and convert it into value between 0 and 1. And next we create the data set of our training, the training set we want to train our data. So we split our data into xtrain and bytrain. So what is xtrain? Xtrain contain our we are analyzing data of 60 days. So in xtrain we have data containing first 59 values, means 60 days value, like 0 to 59 we are having in xtrain, and the predicted value which we came on the next day is in bytrain. So bytrain basically having the predicted value. So next we convert it into NumPy array, and then we reshape the array. And next we build the LSTM model, LSTM modeling, and here we create the LSTM layers. And this 50 50 which are we having in our algorithm. This 50 is the neurons which we provide to our model. So next we compile the model and now we train our model. Here model.fit is basically for the train. And next we provided batch size and echo. Batch size basically means the train is present in each batch. Here we take it one, and epochs means one full cycle of the full training, where our it takes more basically it takes more than one echo to train any neural network, but here it takes only one. So next we create our testing data set, where we create X testing and Y test list. So Y test basically having our predicted values, and next we reshape the data and that we predict price value. So and next we have RMES value, RMSE value, which is root mean square value. So root mean square value is basically for checking the performance, how our program is performing. And next we plot the data that we have come so far in the result, and after visualizing the data we got the result, graphical result like this. The blue is our train data, and and VL, the one in Z, this is showing our closing value of current, which is the current closing value, and the yellow one is showing the predicted value which is predicted by our program. So next, as we have graphical representation is only not enough, so we here we showing our values in numbers. This is the cost, the closing cost. So next next is here we have if we summarize the program, and here it is our predicted value, and of a certain day, like as Apple on few 15 they predict the price by 120, and next, oh, sorry, is predict our price to 150, and then we analyze our program with the closing value of Apple at that day, and that is closed by 125, which is nearly closed but not so close, but it is our predicted value. So that's our program.